You know that feeling, right? You walk into a store and the lighting is just perfect. It makes everything sparkle. But have you ever wondered what's going on behind the scenes to make that happen? It's not just about plugging in a few lamps. There's a whole hidden world of codes and calculations, and today we're going to uncover it.
I mean, you see the final product, that dazzling display, but what you don't see is the invisible framework that keeps it all running. How do they make sure the lights don't flicker, or even worse, that a circuit doesn't just completely blow? Well, that's exactly what we're going to get into.
You see, just like any building needs a solid blueprint, a big lighting display needs a code. It's basically a set of rules that ensures every wire, every switch, and every light bulb works together perfectly. And, most importantly, safely. Yeah, when you're dealing with this much electricity, you can't just wing it. It's a real science, and it's governed by a very specific set of rules. This blueprint is what separates a brilliant, glowing display from, well, a dangerous fire hazard.
So let's meet the main character of our story today. It's the official rulebook for pretty much everything electrical in the United States, and it's got a very official-sounding name. So what's the NEC all about? Well, it's way more than just a dry technical manual. Its number one job, its whole reason for existing, is safety. It's designed to protect people and property from all the things that can go wrong with electricity. It's really the gold standard for the entire industry. Honestly, the best way to think about the NEC is like the ultimate safety manual for electricity. It's a massive book, so today we're just going to zero in on one small but super interesting part of it from Chapter 2. And it's all about how you calculate the power needed for lighting. Okay, let's start with that classic, eye-catching feature of any retail store, the show window. You might think you can just hang as many lights as you want in there, but nope, the code has a very specific rule for this. And here it is, right from the NEC itself. For every single foot of a show window, you have to budget at least 200 volt amperes of power. And believe me, that's not just a friendly suggestion. It's a hard and fast rule. The key number to remember here is 200. Now, volt amperes sounds kind of complicated, but it's basically just a measure of electrical power. Think of it like this. For every foot of that window, designers have to make sure there's enough juice in the budget to handle 200 units of electrical load. This is what keeps the circuit from getting totally overloaded. And the math is surprisingly simple. Let's say your window is 10 feet wide. You just multiply 10 by 200. That gives you 2,000 volt amperes. So the electrical plan has to be able to handle at least that much power just for the window display. Easy enough, right? But what about other kinds of lights? Okay, so what about another incredibly common feature in commercial spaces, track lighting? You know, it's versatile, it's modern, and you guessed it, the NEC has a specific rule for that too. For track lighting, the rule is a little different. Instead of per foot, the NEC says you need to budget 150 volt amperes for every 2 feet of track. So if you've got a 16-foot track, you'd think of that as 8 2-foot sections, and then you'd multiply that by 150. But there's a catch, a modern one. The code also has this really smart exception. If the track system has a device that limits the maximum current, which a lot of modern LED systems do, you can just use that device's actual rating instead. This lets you do a much more precise and often lower power calculation, which reflects a way more efficient use of energy. It's pretty cool. So let's do a super quick recap. For show windows, it's 200 volt amperes per foot. For track lighting, it's 150 volt amps for every 2 feet. Two simple rules, but they are the absolute foundation of a safe and effective lighting design. So we've looked at the numbers, but what's the big deal? Why does the NEC even have these super specific rules? Well, it all boils down to two things: safety and reliability. This is the why behind it all. These rules stop circuits from getting overloaded, which is a massive fire risk. They make sure that the beautiful lights you see will actually stay on without tripping a breaker every 5 minutes. And maybe most importantly, they create a universal standard. So an electrician in California is following the exact same safety rules as an electrician in New York. So really, the next time you see a beautifully lit store, remember those hidden numbers. That 200 and that 150, they aren't just random figures. They're the silent guardians making sure that display is not only brilliant, but more importantly, safe. It really makes you think, doesn't it? Our world is just filled with these invisible rules, from the design of a staircase to the way our water pipes are built. So what other hidden codes are shaping your life without you even knowing it? It's something to keep an eye out for. Thanks for joining me on this one.